uh, have another combinatorics counting problem from the SM0 Singapore Mathematical Olympiad Junior 2015 problem 25. And so this is kind of a standard problem. You're given a very long list of numbers, of natural numbers, which you could list if you want to. If you had the time, you could list them and actually count the ones that you wanted. It would be exhaustive, it would be tedious. So we're looking for a more clever way to do it to reduce the amount of effort we would have to do to solve a problem like this. Now, what we have right here is it's a sequence of numbers 20 through 2015, and we're looking for the multiples of 3, but not multiples of 5. Okay, so we want to count all the multiples of 3 and exclude the multiples of 5 because 15 would be a multiple of 3 and 5. Now, just some insight. There's one more than the difference, okay? And one way of seeing that, like 20 and 21, that's two numbers. If you just subtracted 20 from 21, you might naively say there's one, just if you're just looking for a quick one-off answer. But you have to take the difference and add 1. And that's what I did here. There's 1,996 numbers from 20 to 2015, natural numbers. So that, again, you could do that, but that take an enormous amount of time to do manually. So the reasoning here is to note, just like I said earlier, is that a multiple of 15 is a multiple of 3 and 5. But we do not want the multiples of 5, so we have to subtract the multiples of 15 from the multiples of 3. And that's the guiding logic. The rest of it's just details. So what we do is we go ahead and first count the multiples of 15. And it's pretty clear that 30 is the first multiple. You don't see it, the ellipsis hides it, but there's a 30 here somewhere, right? So 30 is the first multiple of 15. Now, the last multiple, that's probably the hardest part of the problem, is 210. And the way to see that is just when you divide 15 into 2015, you would get a remainder of 5. So you would be starting at 2010. 2010 is in the list, and it's a multiple of 15. And so in that way, and using the logic we used a moment ago, there's 133 multiples of 15, 133 multiples of 15. And then, of course, counting the multiples of 3 is the same sort of reasoning. 21 would be the first multiple of 3, right? So I wrote it intentionally as 7 times 3 because that makes the counting a lot more effective. And then when you divide 3 into 2015, you get a remainder of, I guess, let's see here, what do we get? You get a remainder of 2. And so that means we would have to start at 2013, which is again in this list, okay? So the same sort of reasoning, you get 665 multiples of 3 in that fashion. And just like we said we had to do at the beginning, we have to subtract this value from this value. And so you actually get 532 multiples of 3 that are not multiples of 5. I thought it was a nice little problem. Let me know what you thought, and let me know if you think of a more efficient way to do it.